I don't think people understand how a tiny electron swap makes salt, and fireworks in chemistry class. Ready for a fast tour of ionic versus covalent? Let's go. Start with sodium. It has 11 protons and 11 electrons as an atom, but it really wants to lose one outer electron to feel stable. Lose that electron and you get Na+, 11 positives, 10 negatives, net +1. Chlorine? It has 17 protons and grabs an extra electron to become Cl, 18 electrons, net 1. Opposite charges attract. Na++ Cl stick together as NaCl. Ionic bonding. This is the classic metal meets non-metal story. Metals donate electrons, non-metals accept them. Group 1 metals, lithium, sodium, potassium, all behave similarly. Potassium is the drama queen. It loses its outer electron most easily because that electron sits farthest from the nucleus. On the other side, fluorine is the eager electron taker, even more so than chlorine. Some atoms swap more than one electron. Magnesium loses 2 to become Mg2 plus oxygen, gains 2 to become O2, MgO forms. If Mg meets chlorine, you get MgCl2, 1 Mg2 plus holding 2 Cl partners. Contrast that with covalent bonding, non-metals sharing electrons. Hydrogen and chlorine share a pair to make HCl, 2 hydrogens share to make H2. Nitrogen shares 3 pairs with hydrogens to make NH3. Ionic is give and take. Covalent is sharing. That tiny electron move? It's the reason your food tastes like salt and why molecules behave the way they do.